Now, okay, now for the chapter, what you have to do, chapter 9. I think it's the best way to do is to type directly in the Moodle, so it will be saved directly there if you want to follow and just come to this. Now, so one to 16, 21, 22, 23. Actually, question 20 can be solved as well. 27 and 31. And we have chapter 8. If I go to the chapter 8. From 1, 14, 15, 16, 17, 18, 19. Okay, so from 1 to 19. They're all similar questions. And is there anything else that I want you to concentrate? Okay. $27, $26, $25. So 22, 23, 25, 26, 27. That's great. Okay. $27, $26, $25, and 22, 23. 22, 23, 26, 25, 26, 27. So these are the questions that you have to solve for the quiz and for the exam too. The solution, I'm going to upload it for all of it. If you have any questions, you can just get in touch with me and ask how the questions are being solved actually. I will be very pleased to help you. Now, I'm done with attendance. Okay. Okay. Now, if you go to the question which is in the 9 that I wanted to discuss about the convexity. Convexity, I have not told you anything about, but you should have known from the previous if you have taken any financial institution management. So convexity is measuring the relationship between bond price and the bond yield. Or if you want to put it into simple words, it is the measure of how the duration of the bond will change as interest rate changes. So there is one question, very good question. It deserves to be solved. Question 31, if I'm not mistaken. Here. So this is the question. MLK Bank has an asset portfolio of consisting of 100 million. Even though I'm going to provide the solution to you, okay, I'm going to provide the solution to you. However, I want to go over it because I want you to pay attention to more specifically to the cases. So let me ask the question in this way. Have you ever seen this subject, especially the convexity, before? Is there anyone in the class who have seen it before? It seems no, yeah?
Yes, I have seen that in your previous course, actually.
Yes, you have taken financial institution management from me, yes?
Yes, yes, in the summer.
Yes, that's good. That's good. That's going to be better for you to understand then. Is there any? Okay. I know have seen it. So that could be a kind of revision for you. Now, you're given a bank with asset portfolio with 1,000 bonds and 100 million and 30-year on an 8% coupon rate. So they're given like changes in terms of percentages in the market yields. Okay, if the new price, if the market yield changed immediately by minus plus 0.10% and plus minus 2%. So we'll try to see how the changes. So the convexity in here is applied to show how the price will be accurately predicted with the convexity, and how it's accurate, how it's predicted without convexity. So I provided this type of solution to you. So for A is given here. The formula is here. So what you do here, you calculate the bond value, which is $1,000, just present value, and calculate the bond value. We know that the coupon rate and face value, maturity, and the YTM, the yield to maturity. If you know this all, you can easily calculate the bond value, and then adding this minus 0.10% to the YTM, calculating the bond value, and plus 0.10% to YTM as well, calculate. So in this way, you calculate the bond value in this manner. And the same thing you do with minus 2% and plus 2%. As you can see what happens to the bond value. In second question, you're asked to find the change in price, okay? You're asked to find change in the price using the duration formula, okay? Minus duration, and duration is given, which is 12.16%. So what do you do here? You calculate change in the price, okay? You calculate the change in the price. According to this formula, you put the duration, 12.6, change in percentage rate is minus 10%. You put it here. So minus 10 is this. Divided by YTM, the rate is 8%, and times the value we get it actually, 10,000, 1,000. And the same thing with plus 10. This is only the changes. Then you add them up to the 1,000, to the bond value, which is given here. And you get actually the real price of the bond with the changes including. The next step, you compare how the price with the duration value will be and what will be the price with the market value estimation. As you can see, if there is a small change in percentage, small percentage change in interest rate, the error, the prediction capacity doesn't vary much. So there kind of doesn't go that much deeply. However, as you can see here, that when the percentage change in the interest rate goes a bit far, then the prediction actually probability goes down. The error increases of the prediction. So using the convexity, this is part B. Using the convexity, it helps you to reduce that error. It helps you to reduce that error. The convexity formula is used, the percentage change in price with the convexity is using this formula. So I'm going to put this file as well into Moodle. You can get the benefit of it, okay? You can get the benefits of it. So if you have any questions, I'm pretty sure that you shouldn't have any questions because everything will be obvious. And please study hard, and if for somebody it can be a revision, but still the question will be kind of tricky and challenging. But you will not be responsible for anything that you have not seen in the class. Okay. Now I will use the same data that I have been using it before. The data will be, but before using that data, where is it? So you all have taken the correlation, you have taken the statistical courses, and you know what is the correlation and linear regression. If anybody who can remind me about the correlation, the linear regression. Okay.
Correlation measures how two variables affect each other. Like
Okay, they measures the relationship. Okay, there are two variables, and you try to measure the correlation through the variables. Okay, and linear regression. Have you ever heard this terminology before? Some of you might heard it in some of the courses, but have you studied it before? Linear regression.
Personally, I saw it many times, but I don't know what it is exactly.
Okay, okay. So actually, correlation and the linear regression is used. Actually, not the linear regression, the multiple regression, but it's just example of you adding. You're trying to estimate. So let me go with the regression itself, and then I'll come to the multiple regression. So in regression analysis, we have a dependent variable and independent variable. Dependent variable is the variable being predicted and estimated that we used to do before, like using net interest margin and so on. Independent variable provides the basis for estimation. They're explanatory variable, they're predictor variables. Okay, you're using the variables to predict. So have you heard terminology? You heard it, but if you remember, H0 and H1, which is null and alternative hypothesis. This is null hypothesis, and this is alternative hypothesis. So null hypothesis and alternative hypothesis. In null hypothesis, these are the hypotheses. If you have got any hypothesis saying that, for example, my hypothesis, we coming from the previous case, NIM is equal to, let's say, cap plus cost to income plus NPL plus liquidity, like the ratios from the camel approach. Okay, we are trying to use how these variables, how the cap, how the cost to income, how the non-performing loans, how the liquidity ratios affect the net interest margin. Okay, and this is called actually multiple regression analysis. But when it's linear regression analysis, we're only measuring effect of the cap on the NIM. Okay, this is called linear. But if it's multiple regression analysis, then we are adding more variables, more than one. This is what we call a multiple regression analysis. So these are independent variables. So they are independent from each other. This does not affect this, this does not affect this, this does not affect this. And net interest margin is a predictor. Actually, it's a predicted variable. This is called kind of regressant. At the same time, it is the variable which is depending on the variables that we are trying to use, like explanatory variables. So this is dependent, and these are the independent variables. And we are using here now an alternative hypothesis, like if my hypothesis can be how the capital adequacy, or let's do it about the liquidity. How the liquidity affects my net interest margin. Okay, my expectation will be affecting negatively because more liquid banks, less profitability it should expect because it has more cash in hands. That's why the liquidity will be, the liquid ratio will have a negative impact on the net interest margin. So my null hypothesis will be in the following way. My aim, my purpose is always to reject the null hypothesis and accept the alternative hypothesis to support my statement. My statement is that liquidity impacts net interest margin negatively. So when we have this in example, you will understand better. And then we'll come at the end when everything is counted, everything is estimated, you should have come up with certain recommendation, with certain advice. Okay. So we are given here a scatter diagram of number of the sales calls made and number of the copiers sold that month. Okay, here, as you can see here, and this is the scatter diagram. As you can see, they're going upward, sloping. So most probably we're expecting a positive correlation between them. So, and coefficient of correlation is ranged from -1 to 1, or from -100 to 100. If it's more than 50, it is a strong correlation. If it's less than 50, it's a weak correlation. It can be minus 25%, which is weak negative correlation. They're negatively correlated or positively correlated. So this shows that they're negatively correlated. This diagram shows that they're positively correlated. This is what I was explaining, okay? So minus 100 and 100. If it's less than 50, it's weak. If it's more than 50, it's strong. Okay. Before when the softwares were not available, the people, they used to calculate using the Excel spreadsheet and using what do you call it, manually, calculation manually. It takes the time actually. This is what I don't actually go with. So as you can see here, 0.75, which is 75% of correlation. So they do the calculation of the correlation in this way. But it's really time-consuming thing. But in Stata, it's just type in some words and put enter, and you get the correlation done. So there's a hypothesis that you're saying that null hypothesis and alternative hypothesis, correlation coefficient is equal to 0, which means that correlation in the population is 0. So there is no correlation. If you fail to accept the null hypothesis, and sorry, if you fail to accept the alternative hypothesis and you're accepting the null hypothesis, you will say that there is no correlation. So the number you got here, 75%, is just by random. And it's testing correlation actually. And correlation, it refers itself to, what do you call it? So in here, as we told you, we were using this for the significance value, the validity of the test, whether this number is really trustable. we used to compare with the T table and Z table, or sometimes F table if we used to talk about the variation, then we don't need it now because everything is estimated through the Stata. Stata tells you directly all the answer. Last time when I was showing the results of the Stata, some of you have mentioned there like T statistics and errors that we need to concentrate as well. However, we don't need it because there's some data, some results are provided by the Stata, which really is more than sufficient. So I'll go here. I'll open one Word file. So first step, I will start with File, Import, Excel spreadsheet. Okay. Now, more specifically, importing the data. Okay, we're doing the same thing. We're not doing something new. We imported data. Okay, so now, first step, actually, what we start with. First is File, Import, Excel spreadsheet. This is what you do. Second, you declare the data type, data set. Is it panel data, time series, or cross or cross-sectional? So you declare the data, but we are not dealing with any so we're not dealing with the time series, we're not dealing with the cross-section. We're always dealing with the panel data because we're using different countries and different variables, different years. So we're not using none of like one of them one and the other one many years or something. So the third step, after when declaration takes the place, how we declare using the command xtset ID and years. This is command. I will make it bold. ID. And if you remember this var is years, I should rename it. Okay, rename var to years. Okay, it's renamed. Now I can declare xtset ID by years. Press enter, and my actually panel variable is strongly balanced. So what does the balance mean actually? Balanced means there is a unbalanced panel data, there is a balanced panel data. Okay, there's another thing. Unbalanced. The terminology you should know. Unbalanced. Let me go directly to the Excel file that you could really understand better. So here, in here I have unbalanced, but Stata perceives it as balanced due to the number of the years doesn't have any missing values. So the difference between balanced and unbalanced, if the data doesn't have any missing values like here, this is called balanced. If the data have some missing, if the data has some missing values like empty cells, then we call it as unbalanced. So in our case, our data set is unbalanced. It doesn't have it's like the cells are not filled fully actually in here. If it was this part, okay, if I was estimating this part, so I could say that this data is totally balanced. There is no any missing values. However, in reality, in our case, our data set is unbalanced. So this is what we do. And if you want to check for correlation, we can do in the following way. Correl, type just correl, and put the name of the variable. This cost to income. What else? Liquidity. NPL. I have Boon. I have LGDP, and Z score, the financial stability. Now I can, if I press enter, I can see the correlation between the variables. So the correlation between capital adequacy and net interest margin is 69%. So who can tell me, is it strong or weak correlation?
So strong correlation.
Strong correlation. What about this between the liquidity?
It's weak.
It's weak. And is it positive or negative? It's positively correlated or negatively correlated?
Positively.
Positively correlated. Look, actually, correlation is used to predict the signs in regression analysis. My question to you, what do you think that the correlation results will be matched with the regression results? Regression is when you're trying to estimate how independent variables, these are the independent variables, cap, CI, leak, affecting the dependent variable, which is NIM. So actually, in reality, the correlation signs like negative plus does not match with the regression analysis, because the regression analysis tells you more realistic picture. So this is what do we get the correlation. So we can type, I can just copy this, put it here. That measures correlation. Then my turn is to run the regression analysis. My turn to run the regression analysis. I just type, actually I can press on the left side and just regress, type the regress, which is regression analysis. In here, as you remember, I was measuring how the CAP, cost to income, liquidity, NPL, and bond indicator, and LGDP and Z score affecting my profitability. So this is my result. If you compare the liquidity, okay, if you compare the liquidity with the correlation, as you can see, it's a positive, but liquidity in here is negatively affecting. So in here, my concern is coefficients and p-values. Now, I will take this data. Actually, I will take this result. You know what I will do? I will reduce the, I don't need any macroeconomic factor. For this time, I will use only the microeconomic factors, the business, the bank specific factors. So I will use only this. So I will use this result. So regress. I put the result. Okay, this is my result that I got it. Okay, not this one. I need the full. I select all. Copy as a picture. You can copy as a table if you want to put it in, if you want to paste it in Excel file in order to make it editable. But for this time, I'll copy it as a picture. I'll put it here. So this is my result. Okay. Now I will interpret one by one everything. First of all, I have to write the model. I have to write the model. Okay. I have to write the model first of all. But writing the model, I will just go to my article because the variables that are here. This is okay. This is the model, but I think it's better to use. Anyway, I'm going to use this model. Just skip it. Now we have name. So we have beta, but I want to use the beta symbol here. Here we go. Beta 0. Now, beta 0 plus beta 1 plus beta 3 beta 4. So I will explain you what each beta means in here. Why do we need him? Why do we need them here? Do we have how many betas? 1, 2, 3, 4. Okay. We don't need beta. So we and plus E, or it's error term. So in here, I'll put cap. In here, I'm gonna put CI. In here, I'm gonna put liquidity. And I think I should have one more beta. Beta 1, beta 2. Beta 3. And I'll put liquidity here. So it should not plus and NPL here. So all of the variables I put cap, cost to income. So capital adequacy measures the size the bigger the company, so on. And cost to income measures the management efficiency, liquidity measures the liquidity, and NPL measures the asset quality. And error term, so the coefficients here, betas are called coefficients, okay? So these are the coefficients will be replacing the betas. They will be replacing the beta. So if you want to replace, so first of all, you should do economical interpretation. This is the first thing in your analysis. If you're working in a specific company, in a corporate finance, in any financial institution, if you're a financial analysis, if you're doing the regression analysis, you should start with the economical interpretation of your model, okay? You should start with economical interpretation of your model. Then you should check the validity of each coefficient. And validity of the whole model. So you're gonna check the validity of each coefficient. This after the economical interpretation. And the last part, you will do R square explanation. So you will see. It's not the last, but before the last one, of course, some recommendation to top management and policymakers. So if you do so, kinda you will be able to explain what article you have done so far. This is your small article. This is small research. So we are doing actually the research now. Scientific research, which is done by scholars. Shubekjan, you can leave, no problem. So economical interpretation. First of all, when we do the economical interpretation, the first thing, we should assume that ceteris paribus if you're putting the economic interpretation, you should go with the interpretation of the model. So you will replace the coefficients actually. Oops. Okay, just a second. Now we just put all the coefficients. Sure. That's why I'm typing so that I can upload it into Moodle. You can access it, okay? Now I'm just step by step explaining what's going on in regression analysis, okay? Now, first, once we start with the economical interpretation, we're assuming that ceteris and paribus, assuming that everything is constant, doesn't change. If nothing changed in the banking system, there is nothing changed in the financial system in this country that we selected, okay, in Central Asian countries, that the financial the profitability banks or financial performance of banks will be reduced by 0.82%. If there is no change, if something, what do you call it? Like nothing changed in this system, okay? Everything's fixed. It's just assumption. Then profitability of the banks will be reduced by 0.82. If ceteris and paribus, if we assume that all variables are constant, only 1% change in size of the bank, which is cap, that will increase profitability of banks by 0.44%. If we assume everything is same, everything is equal, like ceteris and paribus, if we assume that 1% change in cost to income will bring down the profitability by 0.01%. It seems like it's small numbers, but when we talk about the billions, okay, you will see that the number is not really small. Like if you compare, like by how much it will be reduced net interest margin, if your net interest margin is equal to 35 billion, and if it's reduced by this number by 1%, you see, what does it mean? By 0.01%, like 100 basis points, so 10 basis points, that will reduce your net interest margin by $3.5 million. So it might seem that it's a small number, however, it's not really small number. So we should be very careful. Only 1% change, guys, only 1% change. However, if like 10% changes, imagine what happens. What if 5% changes? Imagine what will happen. And assume that 1% change in liquidity NIM will go up by 0.24%. This is which countries we were using, if you remember. This is model for the countries which is Kazakhstan, Kyrgyzstan, sorry, Azerbaijan, and Uzbekistan. So this is Central Asian countries that we are talking, okay? This is the case of the countries that we are actually estimating. So, and the last one, if 1% change in NPL, NIM will increase by 0.81%. So this is the economical interpretation. Okay, this is what you expect to actually explain later in when you're going to check the validity of each variable. Then you could explain how each effect is what do you call it? How each, when you explain each effect, you have to be able to explain the reason behind these changes. Okay, you say that if 1% change in the size of the bank, the cap will make the capital in a capital adequacy will make the profitability to increase by 0.44%. Okay, according to the results, according to the that we got it from the regression analysis, that's okay. However, you need to explain why it might happen. Why increase 1% in cap could bring you this increase in net interest margin. So you should be able to explain it, the reason behind this. I mean, the reason that you think is really validated. So there is no certain reason. It could be your opinion on the banking system. That's why you're a scholar. That's why you're a financial analysis, and everybody is waiting for your recommendation. What should be done in order to increase or decrease? For example, if there's a change in the interest rate takes the place, and the net interest margin will drop down. Net interest margin will drop down according to the duration. So what type of assets in that balance sheet should be changed? If you say like liquidity, and according to the theory, liquidity actually increasing the liquidity will reduce the profitability. Reducing the liquidity will increase the profitability. This is the theory. However, in the case of Kazakhstan, Kyrgyzstan, and Azerbaijan and Uzbekistan, it's a bit different. The liquidity has the positive effect. So increasing the liquidity will bring you more profitability. What could be the reason behind this? I can tell you that if you increase the liquidity position of the bank, that may attract more customers, the investors. Investors will say, look, these banks are really strong and they're really liquid. If we need our money back, they will be able to give it back immediately upon our request. So this could be a reason why the liquidity may have a positive impact on the net interest margin. So if you want to reduce or increase the change the duration to immunize your what do you call it, portfolio, your financial institution, then you should be doing through the liquidity, taking rational impact effect, the impact on the net interest margin that you got from the results. Okay, this is the economic interpretation we make. In validity explanation, when you explain the validity, you should be able to explain why it happens. if it's significant, and so on. So the validity, we're checking the coefficients, okay? These numbers, how much they are valid, how much we can rely on them, okay? Of course, we start with the beta 0. We start with the beta 0 for the validity. So null hypothesis and alternative hypothesis. Okay. So now, null hypothesis tells you that coefficient is not significant. I mean, if you accept null hypothesis, you will say that the coefficient is not significant. But alternative hypothesis says coefficient is significant because it is not equal to 0. Beta 0 is the coefficient, okay? Is the constant number. Okay. My question to you, or my statement, is that when we accept and when we reject the hypothesis, we reject null hypothesis, which is H0. So this is a kind of statement that you should remember. We reject the null hypothesis only if p-value, the probability value, is less than one of the level of significance, which is 0.01, 1%, 0.05, or 0.10. It should be less one of the level of significance. Then you would just reject the null hypothesis. Your aim is to reject the null hypothesis in order to prove that this coefficient is validated. This coefficient is trustable. So if the p-value is less than one of the level of significance, if it's less than 1, then definitely it's less than 5, it's less than 10. If it is more than 1 but less than 5, then you say it is less than 5 and it is significant. So it should be less from one of the significance level. If not, then your coefficient is equal 0, which is saying that your coefficient is not significant, is not validated. Okay, this is golden rule that you should remember. Let me save this file just in case if something goes wrong. First step. Okay, now I'm saving risk management course. Okay, I saved it. Great. Now, this is golden rule that you should remember. So for our hypothesis testing, we are starting with this number. So we start with constant from the beta 0, okay, from the beta 0, which is constant number. So we want to test whether it's statistically significant or not. So this is our hypothesis. Now we can see that we need to compare the p-value and here. This is the p-values and level of significance are 1, 5, and 10%. Now we can compare. Take the p-value of this. So p-value 0.754. 0. So p-value is 0.754, which is more than all levels of significance. So it is more than 1, it is more than 5%, it is more than 10%. Okay. So what we do here, we reject null hypothesis because p-value is 0.74 and which is more than all levels of significance. Sorry, we do not reject. I'm very sorry. We cannot reject it. Our job, our aim is to reject, but we cannot reject. Let me type the aim here. Okay. Our aim is to reject null hypothesis in order to prove the validity of the coefficient. So we do not reject null hypothesis because p-value is more than this. We can conclude that if nothing, if all or everything is constant, the profitability of banks will not change in above mentioned countries. If nothing happens in the economy, like the capital adequacy doesn't change, the size of the banks, the liquidity doesn't change, the non-performing loans doesn't change, your profitability will not be changed. Your profitability will not be changed. So we actually what we do here, we accept the null hypothesis and reject the alternative hypothesis. So this is what we do. Because our p-value is 0.74, which is less than all levels of significance, 1, 5, and 10%. Now, I'll copy this, paste here. Now I will do the same thing, but for the another coefficient, for beta 1. I did for the beta 0, now I'll do it for beta 1. Exactly same thing. Beta 1. I go here, my beta 1 is this, and I can see my p-value is equal to 0. So I come here and put it here. My p-value is 0, which is less than all levels of significance. So actually, we reject the null hypothesis because p-value is 0 and is less than all significance. So we can conclude that everything is constant, the profitability of the banks, not in here. Now we can conclude that our coefficient is statistically significant. It cap positively affects profitability of the banks. Cap positively affects profitability of the banks. Okay. And now I said it's positively affecting the profitability. I'm in here. This is I reject. This was my aim, and I just proved it that coefficient beta 1 is statistically significant. So I can rely on this number. So I can say, if you want to increase the cap, that definitely will increase the. So why do you think it might be affecting positively the capital adequacy ratio? So you could refer to any article who said that capital adequacy is positively affecting the profitability. Any article, so you can search it in the Google Scholar. There is a website that is available for the scholars. The engine machine, sorry, the search engine machine for the articles, Google Scholar, that will only search the articles which has been published. Capital adequacy affect positively profitability. What I'm doing here is always like this. Capital adequacy and the bank profitability. So I can search why this guy supported the prior finding positive relationship between capital adequacy ratio and banks earnings. So the most important thing that revealed by this study, the capital adequacy is an important factor when it comes. So we can search this article, download it, and find why it's positive. Did you get me? So how do I search it? The effect of specific variable. So I start working on this article and trying to investigate why this guy said it's positive. I can use my own articles. Why did I find it? Capital adequacy ratio and bank profitability. So affects profitability. It also analyzed that since the capital adequacy ratio has positive effect, it can be instrumental regularly to assess the economy and establish the level of capital requirements. So this is the reason he might be given. Okay, it's good. Okay, I will stop here. And next time I will continue. When we have the quiz we are going to have on the 30th. It's not going to be long, the quiz. Okay, the quiz is not going to be long. However, just before the quiz, I will just finish everything, and then I'll let you write the quiz. You have any questions? Okay, it seems that there's no questions. Okay, if you don't have any questions, I'm done for today. Thank you so much. Believe me, you will get more everything clearly after when you will do and practice more and more. Thank you so much. See you then next week.
Goodbye.
Thank you. Goodbye.